All right, we're recording now. So before we start the class, I just wanted to show you that thing that we were talking that I sent an announcement out about. Um, so you'll see when you like scroll down the syllabus, and let me go to the part where, all right, so like this is what we're doing every week, and then there's this stuff in here, QEP. This is all optional. Um, QEP stands for Quality Enhancement Program. And so we have decided that the big thing is um, soft skills. So, soft skills is, what's the point in passing English or biology or math? You don't know how to like make a resume, or you don't understand that you can't have mistakes in your resume, or you're late to an interview. I mean, there's a way that we are informally, and then there's a more formal way that we should be depending on what the situation is. Does this have anything to do with biology? No, it doesn't. But whatever happens, like let's say you're going to be a nursing student, you can have your degree. The degree is going to be useless without the license. You can have the nursing license, but you need to get through an interview. And the point of the interview is not to ask about your grades at Nunez. To be honest, nobody's going to give a shit about your GPA at Nunez when you're going to be a nurse. But they want to know, do you have a license? And then they want to know, what kind of person is this going to be to work with? So there's these other things, which we call them soft skills. I personally, this is not my idea, but I was pushing for this because it's extremely, I think, extremely important. Um, if someone calls you for an interview, you can't, don't email back and put it off. Anyway, let me get to the point that you care about. If you decided to do these, and by the way, I'm putting these are just like rough like weeks that you should be doing these in. If you were kind of pacing yourself out, if you wanted to do them faster than that, that would be fine. But so at the end of it all, you get like a certificate. And then if you have the certificate, I will take any test and I'll replace it with the grade that you got on the certificate, like the average of all these things. Um, some of them are short, some of them take a little bit. It's it's not super quick, but it's not overwhelming either. I mean, I did this last semester. I piloted it with my AMP2 class, and um, let's say out of like 30 people, I think about 20 did it, and then there were about like 6 or 7 people that are like, no, this is just too long. I don't want to deal with it. Right. So they just took all their tests. Right. Most people use this for their final exam grade, and then they just didn't take the final. Some people figured out that they weren't doing so well in the class, so they took the final to get their grade up, and then they used it to replace like whatever was the most valuable test after that. So what I'm saying is that you could use that anywhere you want. If you go to the announcement, it gives you the website. It gives you the if you use your email that you're using for Canvas. It's that email, right? So if you're getting messages on your email from Canvas, that's the email. And then the password is Conover. It's on there. What else? I it wasn't ready over the weekend. It's supposed to be ready today. It might be ready now. It might not be, but it should be ready sometime today. So it's just that's the only bonus extra credit, whatever you want to call it. I mean, it's not. I guess it's not really a bonus in that I'm not really adding to your grade. I'm just giving you a chance to get out of a test. Or if you failed an exam, and you need like a better score in that exam to get like an A, then yes, this is a chance to do that, right? Most everyone that did this got, I think they were getting around a 92%. So which is an A, right? So that was when I did it last semester. That's the scores I was getting, anywhere from like 88 to 96. I was getting around somewhere around there. It has nothing to do with biology, but it's important. So soft skills are really important. So especially for you younger people. It's crazy. My son works in the mall over at Lakeside, and they like even the managers and stuff. There's no soft skills. Like there's like a schedule, but the schedule doesn't mean anything. Like they'll text him 5 minutes before his shift and be like, "Oh, no, it's sorry, you're good today." Like you can't do that. You're on the schedule. And then the other way around, like they'll call him on like a Saturday morning. "Hey, why aren't you here?" He's like, "Well, what do you mean?" Like, "Oh, we texted you last night." It's like you can't just like, but that's what they do. They just do it on the fly. So,
everywhere
I don't
does
know,
that.
man. It's crazy. What I get it if somebody calls you like, "Look, hey, we need you. Can you come in?" But what about like a schedule then? Like, what if you want to go on vacation? I mean, then you should be able to say, "Hey, look, I'm going on a cruise next week, so I won't be here. Sorry." I mean, that's the rules then if you want to play it that way. I mean, y'all should be able to just not go to work whenever you don't want to go to work. Because they can just call and cancel your shift. I mean, that's money.
I worked at UMC and they do that to you.
That's money, man. If I'm like if I'm making $8, $9, $10 an hour, I'm counting on those hours. Like you're messing me up now. Now you're interfering with bills. I don't know. You got to make like I just assumed you make like a 2-week schedule and then you stick to that, and if you can't work a certain day, you got to get someone else to go fill your day for you. Like you take care of that. But yeah, where do you work that they do that?
I was working at UMC before I went out to have my baby, and I was doing
places like that.
Yeah, I was doing secretary, and I would show up for work, and then they would send me home not even 30 minutes later because we were overstaffed, and I was least valuable.
Yeah, then they got to pay you 4 hours. I mean, you showed up there.
Yeah, she telling the truth. I worked at UMC too.
No, they would only. Hey, you did too. Yeah, they would only pay you for what your time there was. So if I got there and I was only there for 30 minutes, they only paid me for 30 minutes.
Wow.
Mm-hmm. Yeah.
Or they would
a lot of people you got to put your kids somewhere. Oh, that's you put your kids somewhere.
Yep. My kids used to go to a sitter, so I would have to leave work and then come home and pick them up from the sitter, and it was a lot of headaches. And they even do it sometimes with the nurses.
They shouldn't expect any loyalty on their side. If I'm working there and my shift's like 8 to 4 and somebody called me at like 11 and said, "Hey, we'd like to offer you this job," I'm just going to get up. Okay, I've got something better. Goodbye.
The thing was, as a secretary, yes, because I used to work 12-hour shifts. So I would work 3 days a week, 12-hour shifts. And just missing one day of work would mess my whole paycheck up.
Yeah, right? That's horrible.
Because Oh yeah.
And you got bills to pay. That's the thing. I mean, you have a life. Like taking away that much money is really devastating. If it was like
Oh,
that
yeah,
for me when I was younger, man, I was counting I'm like, oh, good. I got 4 overtime hours this week, so that's really like 6 hours. And it was like a big deal for me to have like 4 hours overtime in a week. It was like huge. If you took a day
Yeah.
away from me,
Yeah. It's a
yeah,
lot, especially if you work overnight. And I
yeah,
work night
oh yeah.
shift.
I'd be looking. I'd
I
be
used to be
spending
so
my
mad.
time at that job looking for other jobs. No, I wouldn't be doing my
Yeah.
work. I'd be looking for other jobs. And as soon as someone hired me, bye. I wouldn't even give them 2 weeks notice. I'm out. See you later. I'll give
But
you
they got upset when I told them I was leaving, but I was a month
Mhm.
away from my due date. They got so mad at me. But hey, mama needs to go home and set up for the new baby.
Yeah, you see, there's no loyalty on either side, and they deserve it because the way that they treat us. Well, not me, but
Right.
it used to never be like that. Like when I had these types of jobs in the '90s, I didn't. Schedule was out very clear, and they would never send you home because they got to pay you half the day anyway. So why don't we just find something else to do? Wow. All right. So there's that extra credit. that whole thing, about like getting along with people. It doesn't matter how smart you are if you can't get along with people. People don't want you to work there. They're gonna get rid of you. So it's like stuff like that, right? And so I'm really into this idea. Um, so so yeah, you can replace any test you want with it. Um,
I think I'm gonna be really interested in doing it because I'm in the nursing field, so that's gonna work good for me.
yeah, I mean when they're interviewing you like at a hospital, they're not really thinking. I mean, like between you and me, I mean they'll back this up too, but they're not thinking about like, oh, where did she, does she have her license? You're all the same. You have a license and you went to school. That's why you're applying for this job. They're thinking, okay, we got to hang out with her for 12 hours. Is she cool or not? I mean, that's really what they're thinking. And the other thing is like, they're thinking is like, is this someone that's just going to make us do more work? Like she's going to be incompetent or lazy or someone. And so like, we all have to do more, or, is she just cool? Is she going to be like the rest of us? That's what they're thinking. I mean, that's it. That's the nursing interview. If you get an interview, that's really, they've already decided that you're in every other way, so you don't have to like go through and be like, oh, well, my nursing school was this, and they know that. They want to see if you're cool. So, if you're like looking at the ceiling like this while you're doing that, I mean, there's people that do this. Like you just do it a whole interview and you're kind of looking at the ceiling. It's like weird, right? You're already making it's already awkward for everybody. So it's weird, man. People do that. I've seen interviews where they have a huge resume and they went to all this school and stuff, but they can't make eye contact. They're just like talking and they're like not looking at you and they're looking to the side. And it's like weird when someone's talking and just like doing this. It's like I don't know, man. They didn't understand. You gotta like look. But in little things like not smiling. Crazy. All right. The tests. If you didn't take your first quiz, you've got until tomorrow night at midnight, so plenty of time. It's only 5 questions. there were initially 10, and I took it. So 3 of you took the test when I had 10 questions on. I adjusted your test. I took those off. So there's 5 multiple choice. Just this first one was nice and smooth, nice and easy. 5 multiple choice questions. People are finishing it like in 5 minutes. Good. That's we didn't really talk about anything yet. So, take it by tomorrow night. It's pretty easy. Everyone's getting 5 out of 5 or 4 out of 5, and just look over everything. It's all on that video. Like I said, it was like 20 minutes worth of videos. It explains. It has everything you need to know for that test. So, you're going to have to enter through. I think you enter through Secure Exam Proctor. Or eventually when you go to take the quiz, like I don't know if it's going to do it with mine, but what you're going to want is you're going to want to use Chrome. Like I'm using Chrome, Google Chrome right now. And then you see up here, there's like this gray shield. That's what you want. So that's like the extension that they're going to ask you to download. And then you should be ready to go. It will not ask you for a code. Like there is no code. If it's asking you for an access code, it means you didn't, something's missing. Right. So, yeah, so it's and you know what I'm interested in? Let me show you. I'll even show you the part for all your tests. This is the part that I'm interested in. I don't know if you can, let me do my camera. So, I don't know if y'all can see my phone. I'm interested in that part right next to your, that's the part I'm interested in the most. I don't care about.
You got to bring it down some.
Bring it down.
I want to know.
Now you went too high.
Where your notes are going to be, where people put notes. That's what I want to know. That's what I'm at. When it says show your room, I don't think you have somebody in the closet ready to give you all the answers with some kind of flags or something like that. I don't want, I don't want you to have your phone, and then I don't want you to have like notes right there next to your computer. It's that area right next to your keyboard that I'm really interested in. Other than that, I don't care about what your room looks like. I'm okay with that. I mean, if you had like set up some kind of wireless cheating system, good luck to you. A lot of work.
I'm taking mines on my tablet, but it has a camera on here though.
Okay, as long as it works. I think it works on a lot of tablets.
Okay.
Some tablets it might not, but most tablets, it'll work. It's not going to work on. I'm almost positive it doesn't work on the phone.
Okay.
You could try to at least get a tablet. So yeah, that's it. That's how we're. That's how we're doing.
I have a question about the homework.
What's that?
I just had a question real quick about the homework. I noticed in the lab, when you go to the mastery lab and you're taking your homework, I noticed that if you get a question wrong and you try to re-answer it, it automatically counts against you. And it says you get 5 attempts, but even if you take the first chance, it still counts your grade lower.
Yeah, so like let's say if you got everything right, but then you took like 3 attempts on every one until you can get 100 on everything, your final grade would not be 100, right? It would be like a 88 or something like that. Like it would.
Yeah.
But it won't give you, like if you take it the first time and get a 0 and you take it the second time and you get 100, it's not going to average it out to 50, right? But it won't give you 100. Is that what it is?
Yeah, it does. And then it's not like it gives you okay, so I completed chapter 2. Out of 13, I think I got 8 point something total. But then it sent me like a little pop-up saying you can go back and review, but it won't improve your score.
Yeah, well,
so it only allows you that one chance.
I don't mind at all changing those settings because I actually want you to get hundreds on them. At the same time, I want you to learn. So some people in the class, what they'll do is
They just hit. Yeah.
My son does it. He'll go through he won't read anything and he'll go through all 5 times until he gets the answers. Like,
yeah, I write down my notes. So as I was trying to go back, I was like, okay, well, it's saying I had one more thing open. So I kept going back over and over and over. But it was like when I logged back in, it wouldn't show me what I had that was incomplete. And then when I noticed my score, I was like, oh no.
My kid does that in math class. He just goes over it until he gets it right. And then for stuff that he can't really figure out, he goes to Chegg. And I'm like, okay, that's fine for your homework, but you're eventually going to have to take a test. So you have no idea how to do this math and you're going to fail. But whatever, you can't help it. Chegg gives you all that shit. So, yeah, I'll change the settings. So I'll probably put not 5 attempts, but fewer attempts, but I'll make it that if you get whatever your highest score is, that's your score. So if you get 100, it's 100. Let me make sure you guys are still here. Okay, you're still here. All right. So there's the quizzes. All right. So for this week, I'm going to try to make it to macromolecules between now and Wednesday. All right. So let me jump into the PowerPoint here. Can you guys see my PowerPoint?
Yes.
Great. And by the way, you guys don't have to, it turns out that whenever I end the class, it tells me everyone that had logged into the class. So you don't actually have to leave your name or anything. It gives it to me. So that works out.
Okay.
You don't need to take attendance. Yeah, this is kind of where we're working at. We're starting talking about atoms. That's what we're doing today. And then eventually when you put a bunch of atoms together, you make molecules. And so really out of all the atoms that we're talking about, there's really only 4 that I want you to know. And that's what I've been already pushing, right? Carbon, oxygen, nitrogen, hydrogen, those 4. Because in biology, those are the 4 that we care about. Because that stuff, that makes up 90, as you may or may not know, 96% of everything that's living or that even was once living is made up of those 4 molecules. So, 4 atoms, right? But then those atoms, we put them together to make molecules. So like here's a molecule, right? And all the dots are atoms and those make molecules. And there's 4 different molecules we're going to talk about. So there's 4 different atoms that make up people. And then when you put the atoms together, they make molecules. There's 4 different molecules that make up people also, well, animals. So we'll get to that. It's carbohydrates and lipids, proteins, and nucleic acids. We'll talk about that though. Then when you put these molecules together, we're going to make a cell. And a cell is the smallest thing that's living. And then when you take a bunch of different cells and put them together, that makes different kinds of tissues. So your skin is like one type of tissue, and your muscles another type of tissue. So tissue is just a group of cells, right? And then when you take groups of tissues, that makes an organ. When you take a group of organs, like heart, blood vessels, blood, that makes a system, circulatory or cardiovascular system, right? And then when you take all the systems together, it makes the organism, right? So that's what this slide is kind of showing you. We're down here at the bottom, but we want to leave the semester up towards the top, right? And then for those of you going on to A&P 1 and 2, you're working all up here. But you really need an understanding of the stuff that comes before it. So, for example, like practical things, if somebody's getting Synthroid, which is like a thyroid medication, okay, what kinds of food do you not give them that medicine with, right? Because that Synthroid medicine is negative. It's got like a negative charge, which which you should know, but we'll just go over it again. It's got a negative charge, right? So Synthroid is negative, and it's got a negative charge. It's made with iodine. And so you'll know in the future, today you won't, but like in the future, you're going to know when I say iodine, you're thinking negative. Okay, it's negatively charged. I can't put it with food that's positively charged. So it's going to stick to that positive, and then that person's not going to get it, right? So I can't give them their medication at the same time they're getting fed, stuff like that. Right? These are things like practical things, like as a nurse, you'll know. So yeah, like again, these first four, I mean, obviously there's lots of elements in our body. There's even more than on this list, but these first four are the main ones: oxygen, carbon, hydrogen, nitrogen. And then we had this idea of the atomic number that I definitely wanted you to know. The atomic number is the number of protons. You'll see these in the book. There are different ways to talk about these things. In chemistry, you will learn it this way if you take chemistry. I'm not at all interested in doing it that way. I always stick to everything this way. So actually, let me skip over this slide and see if there's another. No. All right. So this inside here, they're not putting it on this one, but inside here, if you looked at the other video, you saw that it had protons and neutrons. Protons have a positive charge. Neutrons have a neutral, no charge. And then circling around it are electrons with a negative charge. Right? So positives are in the middle, negatives are circling around the outside, and they kind of set each other off, right? So normally, if no one said anything to you different, if I look and I see here two of these little electrons, I'm going to assume that there's two protons in the middle and two neutrons, right? Unless somebody says something different. But otherwise, like I'm just looking at this, like this one over here in the bottom left, I see two electrons going around. So these two electrons are orbiting around. So inside here, I'm making the assumption two protons, two neutrons. So because there's two protons, I know what atom it is, right? So I'm going to go over here to where it says 2 helium. You guys don't need to know that because it's not one of those four, right? So the atomic number of helium is 2. You don't need to know it. The ones you need to know: hydrogen. Hydrogen has an atomic number of 1. That means that there's one proton inside here. Carbon 6, nitrogen 7, oxygen 8. Those are the 4. Right? So there's 6 protons, 7 protons, 8 protons. And if you count the electrons going around it, you see that there are also 8 electrons. But what you notice here is that that first shell or orbit only has 2. The second one can hold up to 8. The second one doesn't have 8 in it. It has what, 6? But it can hold up to 8. See, like this one, this valence shell or second shell has, and then this one has 8. But now if I go larger than that, I got to make another shell. See, so we go down to the next one. Sodium. I've got 11 protons. So that's kind of where we start. So sodium, if I look at a periodic table, I'm going to see the number 11 next to sodium. So then I know sodium has 11 protons. Then I'm going to assume 11 neutrons. And I'm going to assume 11 electrons. So now I start to draw my electrons in. This first orbit only holds 2. Second one's going to hold 8. Third one holds up to 8 as well. If you're like completely lost at this point, or if it's like the first day you're here, I made a couple of videos. Look under pages, and it goes over like everything. So you can totally catch up on this. But again, the ones we deal with, the ones that I'm holding you responsible for, you know, that you have to know the atomic number: hydrogen, carbon, nitrogen, oxygen. You have to know those atomic numbers. And really, you should have an idea about, you should know how to make these if I asked you to draw them. Like, I don't care if you draw them exactly like this, but I would want you to know that you have that middle part. We call it the nucleus of the atom, the middle part with 6 protons and 6 neutrons. And then the first orbit here can hold 2 electrons, and then the second orbit holds 4. I don't care where you put the 4, I just care that it has, that you know that 4 electrons are on that second orbit. And that's what we really care about with atoms. We care about how many electrons are on that outer orbit. Because electrons are they're superficial. They don't care about what's on the inside. They only care about what's on the outside. So electrons, it's like watching The Bachelor, right? They just care about what's on the outside. They don't care about what's on the inside. They're always hooking up and dumping each other and having weird love triangles and stealing from each other and giving back and breaking up and getting back together. That's atoms. It's like being on The Bachelor. That's the atomic world. So yeah, here's some terminology here. So again, this is what I kept pushing. The atomic number is the number of protons in the nucleus. It does not matter the number of electrons or the number of neutrons. For example, carbon has an atomic number of 6. That means 6 protons. It could have more neutrons. It could have more than 6 neutrons. It's still carbon. It doesn't change anything. It could lose all of its electrons. It would then, we would still call it carbon. It doesn't matter. It doesn't matter what you do to the electrons. It doesn't matter what you do to the protons. We're still going to call it carbon because it has 6 protons. That's the atomic number of carbon. So make sure you know those 4 atoms, the atomic numbers. And then the weight is really easy. All we do with the weight is, for biology, we just double the atomic number. So when we want to weigh an atom, we take the protons and the neutrons and we add them together. That's the weight or mass, right? That's it. So the atomic number of carbon is 6. The atomic mass is going to be 12, right? Technically, it's different. It's like 12.018 or something like that. And you know what? Go take chemistry if you want to know why. Well, it's because of isotopes, but okay, so that's it. And you might see some talk in your book about 1.7 times 10 to the 23rd, 10 to the negative 23rd or something. You could ignore that. Because luckily this dude named Dalton came along and he's like, look, this 1.7 times 10 to the negative 20, no. Because that's supposed to be the weight of a single proton or neutron. So they came up with this crazy number and Dalton was like, no, this is stupid. We're just going to call this 1, right? Because we got to add all this stuff together. You know, if I gotta add 6 protons and 6 neutrons, I don't want to call it 1.7 times 10 to the negative whatever. Let's just call that 1. So that's it. We call them Daltons. So that's easy enough. Just double your atomic number. And then isotopes. This is a case where we have more neutrons than protons. Let me ask you this, and you can answer to yourself. What happens to the charge of the atom? What happens when we add more neutrons? How does that affect the charge? Just giving you a minute to think about it.
It doesn't.
It doesn't. Thank you.
Neutrons are neutral.
Really, it strokes my ego when somebody answers questions because I just feel so isolated here in my chair. Yes, yeah, right. They don't have any charge. So then who cares, right? Well, it's crowded in there, right? It's like a car built for 6. And now you put another neutron in there. Now you're putting 7 people in there. It's like, it's getting uncomfortable. At some point, if you take something like carbon, if you put too many in there, it's going to break. The whole thing's going to bust open, right? So if you put six neutrons are in carbon and 6 protons, 6 neutrons. If you put 7 neutrons, it's still carbon. If you put 8 neutrons, it's still carbon, but it's really crowded. If you put 9 neutrons, then it just starts to break open. And all the stuff, you know, all the neutrons and the protons, they start leaking out. So that's what radioactive is. Like at some point, the isotope becomes just too much and it becomes radioactive. And you might be asking, like, well, what point is that? Like, are we supposed to know when it becomes radioactive? No. Definitely not for us, right? I mean, I know carbon's around 8. That's all I know. I don't know the other ones. So, I mean, you don't have to either. It doesn't matter. Just know at some point it breaks open and all those protons and neutrons, they leak out. That's the whole idea behind nuclear medicine, right? So we can take radioactive something, barium, you can drink it, and it'll start, the atoms will start breaking open and leaking out the protons and the neutrons in your throat, you know, in your esophagus, in your stomach. It leaks it all out. And then we could take like an X-ray machine and get like a 3D image of your stomach, right? Because maybe you got a hole somewhere in your stomach or in your esophagus. Like, we need to know where it's at. So you could use it for that. Or going back to iodine, we can give you radioactive iodine and it's all going to stick to your thyroid gland, which is up in your neck. And then that way we could take like, you know, you could take like a machine and get like a 3D X-ray of your thyroid and make sure everything's cool, right? So you're using isotopes for that. All right, so that's what an isotope is. It's right here like I wrote it, more neutrons than protons. I was just showing you when you come across a periodic table, some of them are like really easy and some of them look like pains. This one looks like a pain. Like, I don't know what everything means on this. But there are some numbers I know here. I know what 6 means, 6, 7, and 8. Those are the atomic numbers, right? And then you see some other numbers here, and they aren't exactly what I was saying, but they're roughly double. 12, 14, we're going to call that 16, right? So that's the atomic mass, right? Again, for us in biology, we're just doubling the number. We're not getting technical. So, but most of the elements that we deal with in biology, most of them, not all of them, but most of them are up here in the first 3 lines, right? Once you get down here, this is some crazy stuff that we don't deal with. So I'm just going to fast forward past that. Okay, I think I put this in the last week's. I'm pretty sure I did. All right, so this is the only example for biology that you're going to see. These are ions. So sometimes atoms steal electrons from other atoms. We call it an electron transfer. So we don't want to put labels on these things. So yeah, in this case, we have chlorine and sodium. They kind of got close to each other. And so the really important thing to know about these atoms is that, remember, they're superficial and they only care what's on the outside. They don't care about what's on the inside, right? And so they always want to look their best, and they always want like the most. And the most electrons you can fit on this orbit out here, this outer shell, because they only care about the outer shell. So it could hold 8 electrons, but it's only holding 7, but it could hold 8. So if you look at chlorine, chlorine's like almost there, right? It's almost reached its potential. You look at sodium, it's not going to happen for sodium, right? I mean, sodium's got 1 on its valence shell. So it's not likely that it's going to, it's, first of all, no one's going to respect sodium because sodium's got 1 electron here. So sodium's like a punk, right? Someone's going to eventually come along and steal that electron because no one respects sodium. And that's what chlorine does. Chlorine needs 1 more, so it's going to steal it off of sodium. Now you've effed up the feng shui of this whole thing, right? It was all balanced. Chlorine had, and you don't have to know these numbers, I'm just giving you an example. Chlorine had 17 protons inside, and it had 17 electrons outside, before. And so it was all balanced out. 17 positives, 17 negatives, they all cancel each other out. But now, when chlorine stole that electron here, it threw the balance off. Now it's got 18 electrons and 17 protons. So it's got 1 more electron, and electrons are negative. So you've thrown it all off. So this whole thing is negative now. So that's the important thing that I want you to know. Why you don't have to know like what atom is going to become negative and what one's going to be positive. You will in the future, like after my class. You'll just know certain atoms are always positive and certain atoms are always negative. But I want you to know why. Why is it negative? Why is it positive? And it's positive because it lost an electron. And that's the thing that like gets people confused, because that's not a very positive thing when you lose something, right? But that's what it is. Lose an electron, it's positive. When you gain an electron, it's negative. So in our class, you're not going to have to know when this happens, because whenever it does happen, you'll see a positive or a negative. So you don't have to like stress about what cases do these happen. But I like you to know that a positive thing, because we use these words, positive things called a cation, negative anion. The way that I remember it is that a cation has like this T, which is like a plus, and an anion doesn't have any letter that looks like a plus. I don't know. That's just what I do. So the T stands for positive, plus. And look, we have our first bond. They're going to get together. They're going to get together even though chlorine just stole from it. But, it's like The Bachelor. It's all messed up. So chlorine steals something from sodium, and then chlorine's like, hey, you want to go to the hot tub? Sodium, insecure as sodium is, it's like, oh, okay. Yeah, I guess. Let's go. They get together. The positive and the negative stick together. Opposites attract. So that's our first bond. That's also an example of our first bond here. This is a bond. This is now a molecule. It's salt, right? Sodium chloride. The sodium and the chlorine are now sticking together. So, right, this is the ions, right? Cation, you need to know that cation is positively charged. Why? Because it lost an electron. Right? Anion, negatively charged because it gained an electron. So all the minerals, and you don't have to know them now, but just so you know for the future, they're all charged. All the all the things you get, all the minerals you get in a multivitamin, they're all charged. Iron, phosphorus, calcium, whatever. Everything's got a charge to it. Everything's either negative or positive. So, and that's important to how, as you're going to find out in the future, that's important to them functioning in the body, right? Like, what is it that makes the nerves of your brain fire, or what is it that gives that electrical impulse for your heart to beat? It's these minerals: sodium, potassium, calcium, and it's because they're charged. It's because they're either a cation or an anion. So, but for now, for you, just know why something became an anion, or why did something become a cation. That's all you need to know. Yeah, and then they stick together, and that's solved. You see me with my hand? I'm like pointing to the screen, like y'all can see there. So we're going to talk about 3 different types of bonds. So now we're getting to the place where atoms come together and form molecules. So any 2 atoms or more that come together, that makes a molecule. So there are different ways to bond together. You saw one way already. Positive, negative, that's an ionic bond, the bond of ions. In my opinion, not a very strong bond, because the bond is based on what? Theft. So that's like a bachelor bond. And you know how well bonds work on The Bachelor or The Bachelorette. Sorry. Yeah, even the ones that bond at the very end of the whole season and get hitched, right? Doesn't work out. These bonds here that you're looking at are much stronger. And these are the bonds that are always, like, if you don't know what atoms are how these atoms are bonding together, then you say covalent bond. For example, in this mug, like, I don't know what kind of bond are these atoms using to hold themselves together to make this mug? I don't know the answer, so I'm going to say covalent. I'm probably right. I have no idea, but I'm going to guess I'm right, because I'm just going to say it, because most of the time it's going to be covalent. So if no one says anything different to you, you assume covalent bond. This is a much stronger bond because it's based on sharing, not theft. Sharing is caring. So these are covalent bonds. We call them covalent, meaning like cohabitate, whatever, like together. And then valent means the valence shell. So the outer shell, the outer shell of one atom is going to share with the outer shell of the other atom. So it's just the outer shell. And what they do is, atoms always want to fill the outside shell. So if you take hydrogen, right? Hydrogen has 1 electron going around it. And that's it. But it wants 2. Because it feels like everyone else is laughing at it because it's not reached its potential. So it's trying to get another electron. It can't have another electron. Like, no one's just going to give it another electron. So what it'll do is it'll find another hydrogen and say, hey, look, I'll share my hydrogen with you, electron. I'll share my electron with you. You share your electron with me. And we'll make these 2 electrons go really fast around both of us. And it's going to look like we have 2 electrons. Right? And that holds them together. So each of these electrons is doing imagine it's doing like a figure 8 around the whole thing. Right? So both of these electrons are doing figure 8s. And that's like holding them together. So that's it. They're sharing electrons. This is like shorthand because you're not going to see this in the future. You're going to see something like that with just a dash. And a dash means they're sharing an electron. It's a covalent bond. And then in the future, even more, you're going to see it just like that. H2. And then they're just telling you there's 2 hydrogens. And if I were to ask you, well, what kind of bond is this making? It only says H2. And you have to guess, you're going to guess covalent. If it was ionic, there would be a positive or negative. And I don't see any positive or negative here, right? So then you're going to default covalent, right? Because that's why they don't write these things, because it's assumed it's covalent, right? All these things, water, H2O, whatever, CH4, it says methane, right? They're covalent bonds. No one's telling you how they're being held together, so you're assuming covalent bond. H2O, it's a covalent bond. All right, so look here, there's an equal sign. So that's not 1 dash, that's 2 dash. So what would you guess that would be? I'm going to tell you, just to save you time, that they're sharing 2 electrons, right? So it is possible for atoms to share 2 electrons. Most of the time they're sharing 1. Sometimes they're sharing 2. Just depends. The only time you're going to see this, oxygen shares 2 electrons with another oxygen, just like you see up here. Carbon will do it with another carbon. So carbon shares 2 electrons with a carbon. And here's the third case you'll see. Carbon will do 2 electrons with an oxygen. So oxygen, oxygen, carbon, 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 oxygen. It's the only times you're going to see it in this class. So that's a stronger bond, right? I'm not taking one hand and I'm holding on to my partner with one hand. I'm doing both hands. So stronger bond. That's even stronger. So there's rules with covalent bonding. Whatever you have to share, that's all you're getting back. Let's take the example of hydrogen. Hydrogen only has 1 electron to share. That's not how sharing works. I share 1 with you and you share 4 with me. That's not how it works. I share 1 with you, you're going to share only 1 with me. So that's it. So that's one rule. You only share what you're going to get back. Right? Another rule is you can't overfill your shell. So let's look here. Okay. Do you remember the atomic number of oxygen? You should. If you don't know it, get it in your head, right? So oxygen.
8.
8.
So therefore, if it's atomic number of 8, we're going to assume that there's 8 electrons. So now let's count the electrons. Here's 2, 3, 4, 5, 6, 7, 8. So these 2 don't belong to the oxygen. These 2 belong to the hydrogen. The rest of these belong to the oxygen. So it has, so on its valence shell, it has 6 electrons. It can hold up to 8. So when you're sharing, it's like you own it. So when oxygen is sharing with the hydrogen, that's another one on its valence shell. That's number 7. Hey, oh, you got, wow, good timing. And then same thing here. So these 2 belong to the hydrogens, but because they're sharing, it's like the oxygen has 8 on its valence shell. So that's it. Oxygen we cannot put another hydrogen in here because oxygen cannot overfill the valence shell. That's it. The valence shell This was the second shell. It only holds 8. So done. You can't put 9 electrons on there. So oxygen is limited. Look, in this case, it's sharing 2 with another oxygen. So it's kind of like each of them have 8 on this outer shell. Here, this oxygen went a different route. It's sharing 1 with this hydrogen and 1 with that hydrogen. But it's the same rule. You cannot overfill. That valence shell only holds 8. Done. And look at hydrogen up here. How many electrons go on this first orbit or first shell? Only 2. So that's it. Hydrogen's stuck. Hydrogen can only bond with one thing ever because it can't put more than one other. It can't share more than one electron. It only has 1 to give, and it can only receive 1 in return anyway because you can't overfill your shell. So whenever you look at hydrogen, you're always going to see hydrogen bonded to one thing only. Right? This hydrogen is bonded to 1 carbon. This hydrogen bonded to 1 carbon. Hydrogen's only going to be make a bond with one thing. Oxygen can make a bond with 2 things. Or look at it this way: hydrogen has 1 hand only. So that's it. You can only grab onto one thing. Oxygen has two arms, 2 hands. So I have a choice. I can grab onto 2 people with 1 hand, or I could grab onto 1 person with both of my hands. But I can never grab onto 3 people, right? That's it. Nitrogen does 3. We don't have that on here, but nitrogen will bond to 3 different things. Carbon is like the most versatile. It can bond to 4 different things. So carbon's like the most important out of these 4. So carbon can make 4 bonds. So right here, these are the bonds right here that I just got done saying. You need to know that. You need to know that hydrogen can make 1 bond, oxygen 2, covalent, nitrogen 3, and carbon 4. There are double bonds. We talked about that. There's even triple bonds. We're not going to talk about that. It's not something that you're going to come across a lot. Does anyone have any questions? Covalent bond, sharing electrons. Ionic bond, positive and a negative sticking together. Right, they're ions. They're sharing with ions. Right, not as strong as a covalent bond. There's a third type of bond that I want to show you. But before I can show you, I have to talk to you about like this special type of covalent bond. Covalent bond is sharing. Sharing is caring. One exception. There's one dick in this whole bunch, and his name's oxygen. When oxygen gets around hydrogen, I don't know what it is, but oxygen feels like it can bully hydrogen. And they're not doing equal sharing. Oxygen is not sharing like it is supposed to. So what's happening is like, let's take like an electron. This arrow here is going to be an electron. So electron goes around oxygen, and then it's supposed to go around hydrogen, go around oxygen, like that, right? 1-to-1 sharing. This is not happening here. Oxygen is keeping the electron and then letting hydrogen see it once. And then it's taking it back again. Give it to hydrogen once, then takes it back and keeps it. So anytime you go to check out this water molecule, you'll see that oxygen's hogging the electrons. For this class, this only happens with hydrogen and oxygen. Oxygen just hogs the electrons from the hydrogens. It bullies them. Because remember, hydrogens only have 1 electron. So it's all about what's on the outside, right? So Hydrogen gets beat around a lot in the atom world. It's constantly having its electrons stolen. Here, no, not stolen, just getting borrowed, like taken advantage of. Hydrogen's getting taken advantage of here. Oxygen doesn't appreciate hydrogen. And so, but there's an effect there. So whenever I go to check out a hydrogen is almost, not always, but almost always missing its electron. But if I were to go to oxygen and be like, hey, oxygen, why did you steal the electron? Oxygen's like, whoa, I didn't steal anything. He just had it yesterday for 5 seconds, right? So it gives it an effect of being like hydrogen's, for the most part, missing its electron. But it didn't get stolen, it's just hardly ever there. So it's got this positive pull. It's not like a magnet. It's not like a full ion. It's like, we'll just say it's like a half of a charge, just to like kind of give it a name. So this is kind of like half of a charge. And that's what this D, this is like called the delta. That's what this D means. It means a partial charge. So, and then if you look at the opposite end, the oxygen, it's always got that extra electron, almost always. So it's partly negative. That, we call this a polar bond. It's a covalent bond because they are sharing. They're just not caring. So they're sharing electrons, but unequally. That's the key word. They're sharing the electrons unequally, and it's giving it a slight positive on one end and a slight negative on the other end. So, yeah. You got him on your cell phone plan, paying his rent. He went to McDonald's, again, brought you a small fries, right? That's the relationship between oxygen and hydrogen. And look, it's happening here too. So this is water, right? This is an example of water, right? But it's just doing the same thing here too. So you got a positive pull on one side, and then a negative pull on the other side. So we call this a polar covalent bond. Just means that they're not sharing their electrons equally, and then you've got a positive pull and a negative pull. You're only going to see this in this class. You're only going to see it with oxygen and hydrogen. Oxygen doesn't do this with any other atom. It's not going to pull this with carbon. It treats carbon with respect. It's not going to pull this on nitrogen. It doesn't do this to other oxygens. It wouldn't do that. Oxygen respects the other atoms. It's just hydrogen. And no one else would do this to hydrogen either. Carbon doesn't do it, and nitrogen doesn't do it. It's just this relationship. So look, so you see this, the whites mean hydrogen, and the orange reddish means oxygen. And this is the molecule of water, right? H2O. This is, how many do we have here? We got five different water molecules here. All right, so we're not talking about, so this is the hydrogen bond I was wanting to tell you about. And you can kind of see what it is already. You have 2 hydrogens and 1 oxygen. So this is a water molecule. So is this one, right? And they're even showing you, here's the covalent bond, but it's not a regular covalent bond, right? It's polar, or they'll call this non-polar. It's not a non-polar bond, or it's not like a regular covalent bond. It's a polar covalent bond. They're not sharing equally. So you've got this positive pull here. You got a positive pull here. You've got a negative pull here. So the partial positive attracted to a partial negative. That's going to kind of hold one water molecule to another one. They're not sticking together. This is not like two magnets sticking together. It's not like an ionic bond. We have a plus and a minus, and they're together. Right? No, these are kind of like attracted. So they're, if I take this water molecule at the top and I like gently tug it and I pull it, these other four are going to follow. But if I grab that top one and I just rip it off, it's going to come off because the bond between them is not a strong bond. So hydrogen bonds are weak bonds. So we've talked about three: hydrogen, covalent, ionic. It should be in this order. Hydrogen are the weakest, then ionic, and then the strongest are covalent bonds. And of course, the polar covalent bond is not as strong as the regular covalent bond. I mean, just think about like what's their relationship. Sharing equally, that's a strong relationship. Sharing unequally, not as strong. Right? Definitely not as strong. Theft, that's weaker. This is like the weakest. This is based on, like, ultimately it's based on disrespect, huh? Because oxygen is disrespecting hydrogen. So the relationship of water is based on that. So nevertheless, that's what makes water stick together as like liquid, right? If you were to put this on a kettle and boil the water, you know, obviously the water turns to steam, right? But is steam water? Yeah. Steam is still water. So are you breaking, when you heat water up on a stovetop, you're not breaking these bonds. It's still water. You're breaking the hydrogen bonds. So this water molecule goes its way, that goes that way, this goes this way. Right? You're breaking all the hydrogen bonds, and all these atoms are just, I mean, all these molecules, all these water molecules are just like leaving. Right? So let me check my time. Because I don't want to go like too much the first day. All right, let me talk a couple things about water. And then I'm probably going to end it with that. And I'm going to give you some videos to look ahead on. So water has some interesting properties that that other liquids do not have. And one of the properties of water is that it has a high surface tension. Did I make it a slide? No, I didn't. I just have people's. Water has a high surface tension, meaning that it can act like a solid for a small amount of time, right? So to give you a more practical example, you know, you always hear premature babies, if they're born early, they got to stay in the hospital. And what is it about premature babies that they have to stay in the hospital? Like, what is it about their body? Do they have all their fingers and everything? I mean, you know, why they got to stay? Why can't they just go home right away? What part of their body is usually the issue?
The lungs.
The lungs. The lungs are always the issue. It's always the lungs. It's because our lungs are wet, right? They have to be. They can't be just dry. So they stay wet, moist. But you have a problem there because now you need to get oxygen from your lungs into your blood. And you've got a layer of water that's keeping the lungs wet. But that water is acting like a barrier and keeping the oxygen from going into the blood. For us, it's okay because we make a chemical that's called surfactant. We make this chemical that allows, it lowers the surface tension of water, right? If I put surfactant into this pond, this water strider is going to sink right into it. So our lungs can be moist and let the oxygen through. But with babies, they don't make the surfactant until the very, very end. So when they're born too early, they're not making surfactant, and they cannot lower the surface tension of water in their lungs. So the oxygen can't get past it. So that's why they're kept in the hospital, waiting until they can produce that surfactant to lower the surface tension. So that's the reason they're kept in. It's not that their lungs are physically like not ready. It's just that the cells of their lungs aren't making this chemical that will lower the surface tension, because water has a high surface tension. Water cools as it evaporates. And we need this tennis, old Andre Agassi to prove it. You don't realize, but if you didn't sweat all of a sudden, you would know. You would overheat. Today, you would overheat. Right? We don't feel it. Like I'm not sweating right now, but I am sweating. I just don't realize it. And it is cooling my body, even today in January. So water evaporates as it cools. It expands as it freezes. I don't know how important that is for us in biology, but water is cohesive. Water sticks together. Have you ever seen, like, when you spill something, you notice that the water will kind of pull together? And if you take a paper towel and you put it up to you could just take the corner of the paper towel and put it up to the spilt water, the water will all start going in to the paper towel. Like you don't even have to wipe it all up. If you just put it there, the water will go into the paper towel because it sticks together. And water is a universal solvent. So I want you to know these words here because they're used a lot. Solvent is the thing that dissolves. For example, if you're making, all right, let's take cough syrup. Cough syrup, the idea of cough syrup is that you're trying to get acetaminophen, whatever the medicine is, you want to get that into your body, right? In the case of NyQuil, the solvent is not water, it's alcohol. Alcohol is the solvent. The Tylenol that's in it, that's the solute. So the solute goes in, it's the thing that's going to dissolve, right? So the solvent is alcohol, the solute is the medicine. The solution is the bottle of NyQuil that you drink. Here I'm putting it with, I've got that example here too. Yeah, so I'm using the other example here of acetone. That's like another, like nail polish remover, nail polish. That's like another example, right? The paint, I made a mistake here though. The paint is the solvent, is the solute. The paint's the solute. The solvent is the acetone. The best one's the one at the top. Kool-Aid powder is a solute, and the sugar's a solute, right? Because you're pouring that into the water. And so what's going to dissolve? Does the water dissolve? No. The Kool-Aid powder dissolves. The sugar dissolves. That's the solute. Water is the solvent. So there you go. Solvent and solute. You need to know what a solute is. So water is like the best solvent out of all the liquids. Water like dissolves the most things. Okay. Any questions up to that point? I was just talking about some stuff, some properties of water that made it kind of unique. We're almost at the end. See, that's it. Almost there. Last thing I want to talk about is pH. So let's look at this water molecule. We will take, let's not look at it this way. Let's look at just at this one. So my question to you is, let's just look at this one that I'm circling, this one water molecule. What kind of bonds do we have between oxygen and hydrogen? What's holding this oxygen and hydrogen together? Okay, you can answer to yourself. I hope you're saying polar covalent bond. So polar covalent bond. Just making sure you guys are even here. Okay, good. All right. I'm always afraid that I'll lose connection and I'll talk for an hour and everyone's gone. Yeah, so they're covalent bonds. These are covalent, polar covalent. So unequal sharing, right? Oxygen's being a dick. It's hogging the electrons. And so sometimes one of these hydrogens will look over at this other hydrogen and decide, like, you know what, this is just too much. This oxygen is like hogging my electrons and doing it with this other hydrogen. And, you know, I don't want a part of this. I don't want to be a part of this triangle again. Like I'm out. I'm out. And the hydrogen, one of the hydrogens finally gets up enough nerve and it says, I'm out of this relationship. And you know what? You keep your electron. Whatever, I'm out. I'm walking away. I'm done with this toxic thing. Keep the electron, bye-bye. And the hydrogen leaves. This hydrogen right here is going to leave. That's it, it's gone without its electron. So the question is, what can I say about this hydrogen now? It left without its electron. What is it? I mean, what's special about it? It's going to be positively charged because it lost an electron. It's going to get stolen anyway, right? Hydrogen's always getting picked on. You often find hydrogen in your body positively charged. You're always going to see it. H plus, H plus, H plus, H plus. You're going to see it many times. So in this case, because it's an H plus, because it left, now you have this OH, that relationship's still going on. This hydrogen's like, oh no, I still want to be with you, I love you, and they're still together. But if you look at both, so see here they are. They stayed together. But this whole molecule now is negative. Because that hydrogen, when it left, it's like, I don't even want the electron. You keep it. So the oxygen kept it. So now this whole molecule here, we call it hydroxide. It's OH, and then the whole thing's negative. So this is how they drew it. Don't worry about this one. Hydronium, just forget it for now. OH negative. So now you've got two things. On one side, you have this H plus, which is we call it a proton. It's a proton because it's just a hydrogen without its electron. So it's a proton. We call it a proton. And then on the other side, we have this thing called a hydroxide. So the more H pluses you put into something, the more acidic it is. And the more OHs you were to put in something, the more basic it is, or alkaline. And you see we have this scale here. And this scale, you could look at it as saying, what's the proportion of H pluses in here? I don't know. It's not probably not what it stands for. I don't know what it means, but that's the way I look at it. So when you have the protons and the hydroxide ions, this OH and the H plus, when they're equal in something, we call that neutral. And so we give it a number 7. Right? This scale goes from 0 to 14. It tells you how acidic is something, or how basic or alkaline. Alkaline is the other word. How basic or how acidic is something, right? And These are giving you like examples, right? So the lower the number, the more acidic. It's not the higher the number. So don't ever forget that. Lower the number, more acidic. Higher number, more basic. People tend to think that the higher number is more acidic. No, lower number. Lower number is more acidic. 7's neutral. And each number is times 10, meaning that black coffee is 10 times more acidic than urine. Tomato juice is 10 times more acidic than black coffee. Or we could even go like this. Tomato juice is times 10 times 10, 100 times more acidic. Tomato juice is 100 times more acidic than urine. So each time I move down a number, it's times 10 times 10 times 10. So, again, you'd be surprised. Look, Coca-Cola, stuff like that. It's got a pH of 3. That's what? That's 100 times more acidic than coffee. So,
What would be number 1?
our stomach acid is about 1.8. I would think something like 1 is maybe, I don't know, something that they would use on Breaking Bad to dissolve bodies or something. Like really low. Like I don't have anything that's that low. Something that would do damage to your skin, right? You pour it and the smoke comes up and it starts burning. That type of stuff. In our body, the lowest we go is about 1.8, and that's our stomach juice, our gastric juice. And that's okay because our stomach's got like this thick layer of mucus that lines the stomach. So the acid's protected. It's not going to burn through and burn us, right? But sometimes if your stomach acid gets into your esophagus, that's what you're feeling because your esophagus doesn't have that protection. So it burns. You could feel it, like when you go to throw, if you have acid reflux or heartburn or whatever, that's what's happening. That acid is not protected in your esophagus. Only the stomach is protected. So, and then the other thing that people get wrong is that they think like acids are bad and bases are good. No. Bleach cleans things, right? It's like, it's caustic, it's bad. Like if you get more extreme from 7, if you start going 3, 2, 1, or on the other side, 12, 13, 14, like look at oven cleaner. That's gonna burn your lungs. If you get that in your lungs, it's gonna do some serious damage.
You ain't gonna be able to breathe.
What's that?
You're not gonna be able to breathe.
No, right. I mean, it cleans ovens. I mean, that's what it's called. I mean, what's it going to do to you? Cleaning all that stuff that you haven't cleaned off your oven in 3 years. So it's bases or things that are alkaline, they could do some damage, like just like acid. It's just on the other side. It's just so the further you move away from 7 on either side, the more caustic it becomes. What would you need to know, like in real life, like in the future? Probably like you should have an idea of the pH of blood, for example, and it's 7.4, right? Because it's very important for us in physiology to not have your blood go much further than 7.4, right? You can't go to 7.3. That's too much. It's like acidic blood. You can't go to 7.5. It's too much. You have to stay really close to 7.4, right? So anyway, that's the pH scale. I don't need you to memorize each of these. This is just to give you an idea. But what I do want you to know is typically below 7, we would consider that acidic. and above 7, we would consider it normally. We would consider it basic or alkaline, and that the H pluses, we call them protons. The more protons you put in something, the more acidic it makes it. So this H plus, I want you to start calling that a proton. And when I talk about protons, I want you to think in your head, I want you to have this H plus pop into your head. And you start thinking maybe something about acidic. It doesn't always mean acid. Our body uses protons for lots of things, but this is a very common thing. So there's these two ideas of protons. One, I've been telling you, protons are like the atomic number and they're part of an atom, and that's all true. But when we say proton, like in physiology, when we're talking about the body and not chemistry, we're just talking about the body. When I say proton, you're thinking of H plus. And maybe you're thinking of like acid. For example, I can give you, if you have heartburn, you could take something called a proton pump inhibitor, right? And that tells you what it does. It stops these pumps. It inhibits these pumps that are pumping protons. And now you know the protons are H pluses. Right? So the more protons are in something, the more acidic it is. So proton pump inhibitors, PPIs, are going to decrease the acidity. Is that right, Sarah?
I'm literally.
Oh, good. Never mind. My wife's a pharmacist, so I just making sure. But she's in class, so she's not even listening. So she's like most of you. All right, I think that is my last slide. I was telling them PPIs are decrease the acidity of your stomach.
No, they increase. Wait, they increase the pH of your stomach. Yeah.
They increase the pH of the stomach. That's what she said.
Decrease. Yeah, I guess.
So
yeah.
Notice the word she said. She said it increases the pH. That's the same thing as saying less acidic. Increase the pH, meaning the numbers are going up. So that's kind of like a good point there, right? So when someone will say, okay, this is going to decrease the pH, that's another way of saying more acidic. Increase the pH, less acidic. All right. You guys have any questions? That's a long lecture.
Are you gonna post the notes?
I am. I'm going to post the videos, and I'm going to post this recording as well. I would like the next place I'm going to go is let me stop recording here. The next place I'm going to go is I'm going to start talking about functional groups. So I'd like you to maybe like read ahead. I'm going to post those notes as well on functional groups. That's where I'm going on Wednesday. I'm going to start talking about functional groups. I believe in the book it's like chapter 4. Just look for where it says functional groups. That's it. Hydrocarbons, functional groups. That's my subject for Wednesday.
Is there any specific homework